Hi class. In this lesson, we're going to be looking at sample size, effect size, and power. The first formula we're going to look at, and the first calculation of power we're going to look at, is calculating power from sample size. So you would use this when you've actually already done your experiment. You've already conducted your data collection, you've done some analyses, and you've taken a look and you've found nothing. Which it's entirely possible then that the null hypothesis is true. But you wonder if maybe you didn't have adequate power to detect a difference if it was actually there. So did your study actually have adequate power to detect a real difference if it was there? And you're not quite sure. You think maybe your sample size might have been a bit small, and so how do you figure that out? Well, we're going to use a formula that will help us calculate power from sample size to figure out a priori after the experiment, did we actually have a shot at detecting something that actually exists? So the first thing we have to do is we have to get a table. And as I mentioned, there is statistical software that now does this for you, but if you were going back sort of the old school way, you would have to go back and get an appendix that gave you the relationship between power and something called delta. And delta is just a constant we're going to use in the equation to figure. So delta is a constant that's going to help us look up power from the appendix we just saw. And the formula we're going to use is delta equals effect size multiplied times the square root of n divided by 2. And n is just our sample size. So let's look at an example where we fill in all these values and then calculate power. So in this case, for our example, let's say we have 20 observations made across two groups. And we assume a medium effect size. So the effect size, you could pick any effect size really, but in the absence of actually knowing what the effect size is, often we just go with a medium effect size, sort of the Zen path. So we assume that there's an effect size of 0.50. So our formula now becomes delta equals 0.50, a medium effect size, multiplied times the square root of n divided by 2. Now we add in our n value. So the n, we said the number of observations is going to be 25. So now our formula, plugging in more values, becomes delta equals 0.50, taking the square root of 25 divided by 2. And that becomes 0.50 times taking the square root of 12.5 divided by 2. So when we actually sort of finish calculating that out, 12.5 divided by 2 and taking the square root of it becomes 3.54, and we multiply that by 0.50 and that becomes 1.77. So our delta for this equation is 1.77. Now, in order to figure out power, we have to look that up in the appendix. So in the appendix, you can see delta here and our power levels, and we want to use a 0.05 alpha level, our sort of gold standard. And basically what we're going to do is we're going to say, well, 1.77 is somewhere between 1.70 and 1.80. So it's basically somewhere in between here. So we're going to kind of go, and we see that power for 1.70 is 0.40, and power for 1.80 is 0.44. 1.77 is a little bit closer to 1.80, so let's call it 0.43. So basically our power for this experiment is 0.43. What that means is we really only had a 43% chance of detecting a difference, of rejecting the null, if there really were something actually happening, if there really were a true difference between the groups. So just by looking at it, a 43% chance doesn't seem very high. It looks like this experiment is underpowered, And you might want to go back to the drawing board and recruit more participants, expand the sample, and maybe try again.